Hi, good evening everyone. I'm Rose H. De Pedro and I'm going to discuss for our second report is pavement distress and evaluation. So first, distress in asphalt pavement. So we have a seven basic um, distress mechanism. So first, I'm going to discuss now what is pavement distress. So the term pavement distress is a refers to the conditions of pavement surface in terms of its general appearance. So for example, we have a cracks can be further described as generalized traverse longitudinal and the surface. Pavement disintegration can be observed as a raveling the surface. So we have a distribution of wheel load. So for example, if you notice, this is our wheel. Wait, this is our wheel. This is our wheel or ato ang ato ang um, tire. So if you notice, we have a layer. We have a layer here. So this is our road. This is our highway road. As you remember, in our highway subject, we already studied the layer of our road construction. So we have hot mixed asphalt. So first is a natural soil. So some of our failure because of a natural soil. First layer is a sub base. Second is a base, and the last one is a hot mixed asphalt. So here is the one of the failure, fatigue. Yan, fatigue crackings. Here are the cracks. If you notice yan, usually nakikita mo sa road highway natin yung mga cracks na ganyan. And this is the advanced stage of fatigue cracking. So pinaka ano na to, daghan na kaini siya daghan na siya cracks in our highway. We have a lot of cracks. Yeah. Permanent deforming rotting. So we have wheel and another soil sa base HMA surface. So rotting. So yung rotting is one of our failure. Yung rotting is yung paganyan ang ano niya. Wala siyang crack but hindi siya plain na highway. Yan is also a rotting and HMA layer. Wala siyang crack but there is a failure. Yan. Yan pa baba pa ganyan pa na failure. So in our HMA failure, we have unstable, for compaction during construction, for subgrade. This is a one of our failure here. If you notice, pag po yung subgrade natin, this is the possible failure of our construction road. Next, at thermal cracking. We have a thermal cracking also. Wide thermal cracking. If you notice the difference between the difference versus yan, thermal cracking is point end to end, here from here to here, or from here to here. Yan thermal cracking is, this is also a thermal cracking. So wide thermal cracking, ibig sabihin mas lumapad yung yung cracks of our cracks. So black crackings, here's our black crackings. Yan. Black crackings. So here is if you notice here, meron tayong road sign. We already studied here at our highway construction subject. We have a sign, so cushion, fault zone. Fault zone or watch for cracks in the road. So here, from here to here, may mga cracks. Here also, if you notice here, this also a crack. Yan. From here to here, cracks. So first presentation, we had HMA surface base sub base and ice lenses. So ice lenses can also one of the reason why our construction road is failure. So malambot lang siya, ice siya, lenses. So here, yan, hindi siya plain. The next one here, there's a lot of cracks here. So the next one is also this cracks. There's a lot of cracks because of the ice lens in our sub base, in our before our sub base. Yan. This is a water bleeding and pumping. So possible na may mga plant or may mga source of water sa ilalim ng ano natin na apektuhan yung paggawa natin ng road. So here, depression due to pumping. This is the depression because of our pumping. Mali. So stripping, this is stripping. This is also a stripping. So if you notice, this is the separation of our asphalt from aggregate. Stripping, yeah, there's a lot of picture here, example of stripping. So, raveling. So, if you notice, lumabas yung ravel niya. Yan, tanggal yung asphalt. This is one of the example of yung mga parang grabe ang failure nito. Pwede na parang if you pag nakikita mo lang siya parang na-abandon siya na highway kumbaga pa sa bahay. So flashing bleeding. Yan, flashing bleeding yan. Yan, nababasa. Babasa siya. Yan. This is the polished aggregate. Nagbitak-bitak ang asphalt niya, ang aggregate niya rather. So shoving here, hindi na pantay, may mga bilog, yung parang mga bilog na parang one of the reason is our nito, parang yung naging ice lenses na rin, parang hindi matibay yung lupa sa ilalim. So here, so distress in concrete pavements. So basic distress mechanism is load related, fatigue, faulting, temperature related, low temperature mid slab, crackings, high temp, joint crack distress, moisture related pumping, and the cracking. So yan. So fatigue is location of a maximum tensile stress. So yan, this is our wheel. So PCC slab, so HMV shoulder. Aggregate B, sub-base in nature soil. Yan, longitudinal crackings here. Yan. Yan. This is also a diagonal cracking. If you notice, diagonal siya. Ang cracks. Faulting. Nag-separate siya, parang ang cracking nag-separate siya to one another. Yes, this is the tension and tension. This is night, cooler, warmer. So temperature differential between the top and bottom of the slab. So here, this is our slab. Yan, this is our slab. Terminal gradient related stresses. So this is the night, pataob, and this is the night, pahayang o pataob. Cooler sa baba, warmer. Then sa day, warmer sa taas, then cooler sa baba. Moisture gradient related stresses, variation in moisture content between top and bottom slab. So no rain. So yes, exactly. So pag walang ulan, we have a drier sa taas and wetter sa baba. If mayroong ulan, tension, this is our tension. So tension is wetter sa taas, syempre nauulanan, then drier sa baba. So curling crack or warping cracks. Yan, high temperature joint cracks, distress, expansive forces, joint spallings. So mid slab crackings, yan, sa mid slab siya ang cracks niya. Yan, travel. Yan, grabe naman tong pumping na ito. Yan, yung pumping. Yan, may mga water dyan sa mga pump sa baba na naapektuhan. Yan, decracking, scaling. So we have asphalt concrete composite pavement. So HMA surface. Here, PCC slab and existing joint of the cracks. So reflection crackings and reflection crackings, if you notice, nag-reflect dito, dito, here, and here. Here, lane to shoulder drop off. Pavement evaluation techniques. So pavement evaluation techniques is we have a surface condition, distress service, constructural capacity, and also the surface friction. First is the condition survey, document existing condition, pavement causes, and the duration, identification, repair location, and qualities, identify feasible maintenance alternatives. So this stress characteristics, type, severity, and extent. So fatigue crackings, we have these stress types of asphalt pavements. So here also we have a pavement structural condition. What is pavement structural duration? The structure adequacy of a pavement is measured either by non-destructive means, which measure deflection under the static or dynamic loading. So we have um, So for the non-destructive structure evaluation is based on the premise that measurement can be made on the surface of the pavement and its situ characteristics can be inferred from this measured about the structural adequacy of the pavement. We have a four basic non-destructive test methods are: first, we have a measurement of statistics direction. Second is the measurement of deflections due to the dynamic or separating loads. We have the third is a measurement of the deflection from a failing load or impulse load, and the fourth one is the measures of density of pavement layers. So natakal natin yung mga pavement layers during construction. Yung mga pavement layers, yung mga during construction, yun ay mga pumping. One method measured is statistics deflection is the Benkliman beam, which is a simple hand-operated device designed to measure deflection response of the flexible pavement as standard wheel load. So this stress type of concrete pavements, we have a cracking, spalling, faulting, pumping, etc. So here, severity, low, moderate, and high. We have a low, moderate, and high sa severity. Cracking severity. We have moderate, high, and low. This is the moderate crack. This is the low crack, high crack. Na-notice nyo kanina sa pumping, yun, high crack na yun siya. So, extra high severity crackings. Yan. Uy, parang after earthquake. Parang earthquake itong ano na to, itong road highway na to. So, extent, low, moderate, and high. Distress indictions manual. So, ito ang low severity. Extent, severity, and the large. This is the sign road. Yeah, sign road, dead end. C na sa sunod. Severity. Yan, rating, severity. Yan, mga examples niya yan. Condition distress surveys. Types of condition survey, manual, mechanical, or let me say automated. Sample versus complete, converge, email, converge networks, levels versus level, project level, frequency of survey. So, in our manual distress survey, we have more detail than automated. Slower than automated types, windshield survey, walking, and combinations. So we have also photos. Wide shield, yeah. This is the example of a wide shield survey. Walking survey. Knees and elbow surveys. Oh. Data form. Handheld computer. Ay, ito na yung gamit nila before. Kasi wala pa tayong mga enough na mga our technology. Automated spread surveys, we have more consistent, increased safety, no traffic disturbance, predictable productivity, objectives output, increased sample size, cost savings or long term. Here. Yan. Payment evaluation. I did it to elaborate this payment evaluation ha. Surface condition, distress, or let me say distress, service ability, structural capacity, surface friction. Here, we have the NT product to 200 to 400 measurement per day. So repeatable deflection measurements are used by most states for project and some networks evaluation. Mga evaluation, this is one of the for our evaluation. Pavement responses under load. So here is our wheel again, axle load. So surface we have is soar, base sub base here in a subgrade soil. Deflection for measurement of surface. The NDT load. So here the NDT sensors. We have a sensors. Yes, for testing our highway strong versus weak pavements. So this is the strong versus weak pavements. So the NT load. For our strong pavements, we have here color red. Strong pavements. For the weak pavements here. That's the difference between one. Mas malalim ang weak pavements than strong pavements. So potential result from DTM project variability, subsurface wall support, boil location, load transfer, critical periods in situ, materials property, construction adequacy. Yan. Dynaflect. Yan. Factors that influence measure deflection, load magnitude, pavement factors, transverse location, climatic factors. For testing location, frequency, we have 100 to 500 feet intervals. Typically, outer lane only. So, sa outer lane lang siya. Both directions. Flexible, concrete. Interpretation of NDT. Data. Uniformly projects. So, uniformity of our project design section of rehabilitation, location for samplings, testing or determining payments layer moduli. Yan. Ununiformly or non-uniformly of our project. So here, deflection. Yan, mga garas-garas. Yan. Seismic pavement analyzer, hammer, amplitude sensors, pavement evaluation, surface conditions. Here we have a formula here for skid resistance and interfraction between tire and pavement. So coefficient of friction, coefficient friction is equal to force over our wind force weight. Yes, coefficient of friction is equal to force over weight. Wet condition is more critical. So measurement equipments, our equipment for measurement is lock, wheel, skid, myometer, British pendulum tester, others. Here, myometer. Myometer. Perfect. And this what they want. Black paint. What? Thank you everyone and good evening.